Hello teacher, I am Kanapot Urai Student code is 66360641. And today I will talk about application layer. The outline is introduction, current server paradigm, standard application, and peer-to-peer paradigm. Socket interface programming. About objective, we introduce the nature of service provided by the Internet, the client server paradigm, and the peer-to-peer paradigm. We discuss the concept of the client server paradigm. We discuss some predefined or standard application based on the client server paradigm, such as surfing the web, file transfer, email, and so on. We discuss the concept and protocol in the peer-to-peer paradigm, such as CRUD, Pastry, and Academia. We show how a new application can be created in the client server paradigm by writing to program in the C language. Introduction. The application layer provides the service to the user. Communication is provided using a logical connection, which means that the two application layers assume that there is an imaginary direct connection thought which they can send and receive message. Picture 2.1 shows the idea behind this logical connection. And this is picture 2.1 logical connection at the application layer. You can see this is a sky research and this is connect to other ISPs and connect to other ISPs. Then it's go to another and finally it's go to scientific scientific books. Is a application of a list to application Bob. This is a logical connection and you can see this symbol is describe this picture about providing service. The internet was originally designed to provide a service to users around the world. Sign the application layer is the only layer that provides service to the internet user. It allows new application protocol to be easier add to the internet, which has been occurring during the lifetime of the internet. When the internet was created, only a few application protocols were available to the user. Today, we cannot give a number for this protocol because new ones are making up constantly. And this is the outline about standard and non-standard protocol. Have a standard application layer protocol and non-standard application layer protocol. About application layer paradigm, it should be clear that to use the internet, we need two application paradigm. I mean, two application program to interact with each other. One running on a computer somewhere is the world in the world. The other running on another computer somewhere else in the world. The two programs need to send message to each other through the internet infrastructure. However, we have not discussed what the relationship should be between this program. Should both application program be able to request service and provide service, or should the application program just do one or the other? And it have traditional program client to server and new paradigm peer-to-peer mixed paradigm. In figure 2.2 is an example of a client to server paradigm. You can see this is client to server, and this symbol is router, and this symbol describe the symbol in this picture. About next is example of a peer-to-peer paradigm. The difference is how to connect. You can see this one peer-to-peer. About Korean server paradigm. In this paradigm, communication at the application layer is between two running application program called process. A client and a server. A client is a learning program that initializes the communication by sending a request. A server is another application program that waits for a request from a client. About application programming interface. A program language has a set of instructions for mathematical operation, a set of instructions for string manipulation, a set of instructions for input and output access, and so on. If we need a process to be able to communicate with another process, we need a new set of instructions to tell the lowest four layers of the TCP/IP suite to open the connection, send and receive data from the other end, and encourage the connection. A set of instructions of this kind is normally referred to as application programming interface, or we call API. The online have a socket address, building socket address, and another is server side and client side. For picture 2.4 is a position of the socket interface. You can see this picture have a two side. Right side is a server side and left side is a client side. The two layer is a operating system. Picture 2.5 is a socket used like auto source and sync. We have application program and these three. The keyboard and monitor, or we call desktop. Keyboard read and send to application program, and application program write to monitor to display the file. Application program read and write back the socket, sync and sort in the same. Application is read and write back to. Picture 2.6 is the use of socket in process-to-process communication. We have two sides of picture. The left side is a client process and the right side is a server process. Client process send request to socket, and that socket logical connection to server socket, and the server socket is send request to the server process. Then the server process is respond back, and you can see it go back the same way. And finally, the socket of client process is sent respond to current process. Another figure 2.7 is a socket address. This is a socket address picture. Have a IP address and port number, and we have bits to describe. About our example 2.1, we can find a two-level address in telephone communication. A telephone number can define an organization, and an extension can define a specific connection in that organization. The telephone number in this case is similar to the IP address, which defines the whole organization. The extension is similar to the port number, which defines the particular connection. 2.2.2 is using server to of transport layer. Is a pair of process provide service to the user of the internet, human or program. A pair of process, however, need to use the service provided by the transport layer for communication because there is no physical communication at application layer. There are three common transport layer protocol in the TCP/IP suite: UDP, TCP, and HTTP. And this tree is protocol to describe another page. About the standard client server application. During the lifetime of the internet, several application programs have been developed. We do not have to redefine them, but we need to understand what they do. For each application, we also need to know the options available to us. The student The study of this application can help us to create custom applications in the future. 2.3.1 is a World Wide Web and HTTP. In this section, we first introduce the World Wide Web, abbreviate www, World Wide Web or Web. We then discuss the Hypertext Transfer Protocol, or we call HTTP, the most common client-server application program used in relation to the web. You can see this the topic we will talk about. We have a World Wide Web architecture, uniform resource locator URL, and web document, and hypertext transfer protocol is a HTTP. We have non-persistent versus persistent connection, message format, conditional requests, and cookies. And another we have web caching, proxy server location, and chest update. HTTP security. About example 2.2 is assume we need to retrieve a certificate document that contain one reference to another text file and one reference to a large image. Picture 2.8 show the situation. The main document and the image are stored into separate files in the same site, file A and file B. The reference text file is stored in another site, file C. Since we are dealing with three different files, we need three transactions if we want to see the whole document. About picture 2.8 is an example. 2.2 retrieving 2 files and 1 image. You can see this picture. We have two sites and the client. This site, or we can see, is a reference file, B is a image, and A is a original document. The client requests to site 1 and the site 1 is respond back to client. We give we receive original document and then we client send request to site 1 and then it reply back and then we receive an image then and that image request 3 for site 2 and the site 2 respond back to the client. Then we receive a reference file. Picture 2.9 is browser. You can see this one about keyboard to the process. Is a browser have a controller HTTP, FTP, SSH, SMTP, and the controller have a HTML, JavaScript, and Java programming. And then when finally processed, not sent to display on screen. Example 2.3. The URL http www.compsi/forousan/ this define the web page related to one of the computer in the McGraw Hill Company. The two letters www World Wide Web are part of the host name and are added to the commercial host. The path is comsci slash for awesome slash which define Horizon's web page. Under the directory ComSci Computer Science. Example 2.4 about picture 2.10 show an example of a non-persistent connection. The client needs to access a file that contains one link to an image. The text file and image are located on the same server. Here we need two connections. For each connection, TCP requires at least 3 handshake messages to establish the connection, but the request can be sent with third one. After the connection is established, the object can be transferred after receiving an object. Another 3 handshake messages are needed to terminate the connection, as we will see in the chapter theory. In this figure 2.10, example 2.4, we have a client and we have a server. And this is how it connection. Client send first handshake and the server send second handshake back. Then the client send third handshake and a request to server and then server respond back. And that we will receive a file. then loop again, and this connection, this connect we call first connection, and another loop. You can see we will get image in second connection. In example 2.5, in picture 2.11, show the same scenario as in example 2.4, but using a persistent connection. Only one connection establishment and connection termination is used, but the request for the image is sent separately. In this example 2.5, you can see the client and the server again, and it sends first handshake to server, and the server sends second handshake back, and it's loop like previous. And finally, it responds, and we will get fine. And you can see this one. It's not loop like previous, but this way. The client requests to server and the server respond back. Then we will get image, and it comes to loop again. All of this call connection. About feature 2.12 is a format of the request and response message. In this picture, you can see request line, header line, blank line, and body. This is a request message, and you can see the right picture is a response message, request and response. The topic in layer is a different name. The left side is request line, the right side is data sign. And you can see under picture we have a describe about line, each line get slash doc slash test dot html http slash 1.1 describe to request line, and you can see this one is have a host, have a accept, and have a user agent, have a content. It's all about request header. All of this is a request message header, and another is a request message body. And this one is written about full name and middle name. Another picture is a method. You can see in the table have a method and have a action describe about get. Get is request a document from the server. Head is request information about a document but not the document itself. Put is send a document from the client to the server. Post is send some information from the client to the server. Trash is ensure the incoming request. Delete remove the web page. And connect is the action is reserved. Method option is as action is inquirable available option. And you can see under of this we have described about request line, described about request header, and two of this topic is a request message header. Then under is a request message body. The HTTP trash method is designed for diagnostic purpose. If enabled, the web server will respond to requests that use the trash method. And another picture is a request header names. About header and description. User agent. The description is identify the client program. About accept is a show the media format the client can accept. About accept set is so the character so the client can handle. About accept encoding, they show about the encoding scheme the client can handle. Accept language is so the language the client can accept. About authorization, show what permission the client has. About host is show the host and port number of the client. About date is show the current date. About upgrade is specify the proper communication protocol. About cookie is return the cookie to the server explain later. If modify sign, if the file is modified by a specific date, and you can see under the table. We also the same have a request line, have a request header, have a request message, have a separated by a blank line, separate header and body. About next table is a response header names. Date is showed current date. Upgrade is specified preferred communication protocol. About server is give information about the server. Set cookie is the server asks the client to save a cookie. Content encoding is specified the encoding scheme. Content language is specified the language. Content range is show the range of the document. Content type is specified the media type. Location is to ask the client to send the request to another site. About acceptance is the server will accept the request by pledge. Last modify is give the date and time of the last change. And this is the same previous. About example, this example retrieve a document. See in picture 2.13. We use get method to retrieve an image with the pipe this URL. Request line show the method get the URL and the HTTP version 1.1. The header has two lines that show that the client can accept image in the GIF or JPG format. The request does not have a body. The response message contains the status line and fault line for header. The header line defines the date, server content, encoding, MIME version, which will be described in electronic mail, and length of the document, the body of the document follow the header. This is example 2.6. We can see the client request send the request to the server and the server respond back to the client. About request we use get. About respond we use HTTP. In this example 2.7, in this example, the client wants to send a web page to be posted on the server. We use the put method. The request line shows the method put URL and HTTP version. In 1.1, there are 4 lines of header. The request body contains the web page to be posted. The response message contains the status line and 4 lines of header. The create document, which is a CGI document, is included as the body. See in figure 2.14. It is figure 2.14. We have a client and server the same. The client send request to the server, and this method you can see we use put, and the server send response back we use HTTP. Example 2.8. The following show how a client imports the modification data and time condition on a request. The request you get and the response use HTTP. The status line in the response show the file was not modified after the defined point in time. The body of the response message is also empty. In picture 2.15 show us scenario in which an electronic store can benefit from the use of cookies. Assume a shopper wants to buy a toy from an electronic store named Best Toy. The shopper browser client sends a response to Best Toy server. The server creates an empty shopping chart, a list for the client, and assign an ID to the chart. For example, 12343. The server then sends a response message, which contains the message, the image of all toys available, with a link under each toy that selects the toy if it is being clicked. This response message also includes a set cookie header whose value is 12343. The client displays the image and store the cookie value in the file name BestToy. And this is picture 2.15. Example 2.9 have the client and server the same. The server sends the request by using get method, and server get a custom file is created with ID 12343, and then have an update, and the server send response back by using HTTP method, and we will get a vendor file is created with cookie 12343, and the cookie send the request by get method, and then have an update at a customer file is created with ID 12343, and the server send response back also the same, and then you can see the same cookie request to the server, and the server update again and respond back with HTTP method. Example 2.10. Picture 2.16 show an example of a use of proxy server in a local network, such as the network on a campus or in a new company. The proxy server is installed in the local network. When an HTTP request is created by any of the client browser, the request is first directed to the proxy server. If the proxy server already has the corresponding web page, it sends a response to the client. Otherwise, proxy server acts as the client and sends the request to the web page server. In the internet, when the response is returned, the proxy server makes a copy and store it in its share before sending it to the request client. In this picture, you can see example of proxy server. We have a client, we have a web server, and browser connect by WAN. In summary, applications in the internet are designed using either a client server program or a peer-to-peer program. In a client server program, an application program called a server provides service that another application program called a client receives service. A server program is an unified infinite program. A client program is finite. In a peer-to-peer program, a peer can be both a client and a server. The World Wide Web is a repository of information linked together from points all over the world. Hypertext and hypermedia documents are linked to one another touch pointer. The Hypertext Transfer Protocol (HTTP) is the main protocol used to access data on the World Wide Web, and it's finally. And thank you for watching me for or listening me.